Hello, good morning or good afternoon from wherever you're joining this webinar. Welcome to this webinar and thank you for taking time out to attend this webinar. My name is Pushkaraj. I head marketing at Quintype and I'll be host for you today's webinar. The speaker for this webinar is Rahul. He leads Day of Function at Quintype and is also an AWS specialist. Rahul, you want to give a quick introduction of yourself?
Yeah, hi everyone. Thanks for joining this call. I My name is Rahul. I've been in Quintype for around 2 to 3 years now, and I've been in the DevOps space for around 8 years. So I'm based out of Bangalore currently. I'm actually a native of a South Indian state of India called Kerala, but yeah, I've been in Bangalore for the last 8 years. Yeah, good to meet you all.
Thanks, Rahul. Few housekeeping stuff. If you have any questions during the webinar, please do post them on the chat window or the Q&A window, and we'll try to cover them mostly at the end of the webinar. Before we begin with the webinar, I would want to give a short overview of Quintype. If you can just change the slide. Okay, so Quintype is basically a digital first technology platform. We offer all the tools which are required for a digital publisher to create, distribute, and monetize their content. And our tech stack is hosted on AWS, and Rahul and his team basically manages our AWS instance. To give you an idea of the scale at which we operate, we currently manage over 1.5 billion page views every month across 300 plus publishers. Our team size is over 200 employees, and we are spread across 4 global locations. And now we are expanding aggressively into the digital consulting space. So that was a short overview of Quintype. And without further ado, I'll hand it over to Rahul to start the webinar. Over to you, Rahul.
Yeah, thanks, Prashraj. So today, considering the people who are attending are from various different backgrounds, I'll be starting the session with an overview on Kubernetes itself. So we're going to be talking a lot about Kubernetes today. So I'll just so that we are all on the same page, I will talk about what Kubernetes is, why people move to Kubernetes on a very high level, and we'll talk about a specific problem in the computer side, not just in Kubernetes, but in the software space, which is called a bin packing problem. We'll talk about how we were for a client that we worked with, how we were able to investigate this problem, analyze the problem, and go ahead and right size their applications, make sure they are sized accurately and with optimum costs versus performance as well. And in terms of who this webinar is for, this is for anyone who's on Kubernetes, thinking about switching to Kubernetes, or even for people who are not on Kubernetes, but they can take something away in terms of basically in software, there is no such thing as a silver bullet. Basically, there are various technologies out there, various trends that come up in cloud and in infra, but not any such solution would solve all your problems in one go. There is certain level of management required. With that, I'll start with talking about Kubernetes. Kubernetes was brought about. I mean, we had this entire history of running things all on servers, and from servers we moved to containers. Servers we moved to virtual machines, and then from virtual machines we had containers. Now, once we had containers and we had a lot of containers, we needed something to manage them effectively, and that's where Kubernetes as an orchestration engine came across. Uh, Companies thought that and Kubernetes would solve all their problems just by managing everything for them, but it wasn't as simple as it seemed. Basically, what is Kubernetes? It is a system that automates the management, scaling, deployment of containerized applications. Any applications that are Dockerized or containerized, you can help. Kubernetes can help you with the scaling of it, with the life cycle of it, making sure it's up and running at all times, making sure it is having the right amount of resources based on traffic patterns, etc. And at a very basic level, there is a Kubernetes API layer, which will handle everything from making sure the nodes, which you can link to what are servers, are up and running, and the nodes are able to handle the amount of pods that they have on there. So the scheduling of the pods, etc., will be handled. Uh, so that is at a very basic level what Kubernetes is. Um, I hope that's clear, but yeah, if not, just feel free to raise your hand or put a question across on chat. Okay, so now we'll talk about bin packing. So bin packing is, like I mentioned, it's not just a Kubernetes problem. It's also a age-old computer science problem, where how do you effectively package jobs in servers? Like so, in this case, your containers are your jobs and the servers are your nodes. So how do you ensure that the amount of resources that your container needs is satisfied across your across all containers and placed in an effective way, making sure that you are not uh, overutilizing resources, but you're also not underutilizing them. You have both your cost in check and your performance in check. So Kubernetes actually does a very good job in taking care of this bin packing problem itself. It makes sure that the container, the resources, this can be a CPU resources, this can be a memory resources. It makes sure that based on the available memory and CPU within across the nodes, the containers are placed effectively. Yeah. So any questions before? I mean, I talked about how Kubernetes can solve this problem quite effectively, but any questions before I move on to the problem itself?
Yeah, please put them on the chat window or the Q&A window and we can address them. So far, no
So,
questions.
okay, yeah. So the problem itself. So basically, you can imagine this problem. I'll start off with an analogy. Like imagine you are a logistics company and you have like different sizes of trucks and cars, etc. Now imagine that you place a very small package in a very large truck. That's a lot of wastage of fuel and resources. Your costs are not optimized. You have a lot of space within that truck, but you're not using that as well. And in on the reverse, you can also imagine something like what you see in the picture there, where you try to load a very large piece of furniture on a very tiny car. And that's not going to fit, obviously. So that's not going to work well for you either. So uh, within the bin packing space, within Kubernetes, either of these ends could happen. And that is something that we need to be careful of, making sure that we have optimized everything to the optimum level. So we'll talk about the problem itself that we came across when we started working with a technology client. The client itself had asked us that their AWS bills are going very high. They're having numerous problems in terms of performance, even though they are running on a lot of nodes. And what we observed is that during peak traffic times, so whenever there is peak traffic, this is usually in their daytime noon to lunch time. And during this peak traffic time, we were seeing that a lot of containers. Once we got access to their environment, we saw that a lot of containers scaled up. So the deployments itself scaled up because the traffic was high. There were more number of pods coming up. But as the pods were coming up, what we noticed was all of these pods were in the pending state. So pending basically means that they are in an idle state and they have nowhere to go. So this happens when there are nodes, there are no nodes available where these could run in. But upon further analysis of their CPU metrics, CPU utilization metrics in their AWS platform, what we saw that the nodes for the CPU utilization within the nodes were around 20 to 25%, never going above 25%. And this was concerning, but this led to what we could identify the problem as. Yeah, I don't know if anyone on this chat wants to contribute on what they think the problem could be. Uh, would love to hear some answers on what they think the problem could be. So basically, the scenario is where our CPU utilization is only 20 to 25% utilized, but uh, Kubernetes is telling us that there is nowhere for our nodes to run. Sure. So moving ahead, I mean, I don't think there are any answers in the chat. Uh, yeah. So what essentially, not a worry. What essentially we figured out is that although there was the utilization, the CPU utilization was around 20 to 25. Okay, I have something in the chat. Okay. Um, Yeah, although the CPU utilization was around 20 to 25 percentage, a simple CLI command gave us was that across the nodes, the utilization may be in that small range, but the allocated or the reserved CPU capacity was around 97 to 99% utilized, which means that the pods were requesting for a lot more CPU than it actually needs. So the CPU that it needs altogether was around the 20 to 25% ratio, but the CPU that they were actually requesting for was around 97 to 99%, which is why more number of pods couldn't be scheduled on the nodes. And to understand in deeper on what exactly resource allocation is, in understanding what requested CPU is, we'll have to dig a little deeper into what requests and limits are in the Kubernetes environment. So requests and limits are basically uh, two different configuration elements that is present in Kubernetes to tell the API server or the master plane your deployment, what resources your deployment needs. So limits, requests. I'll start with requests. Requests are basically what you expect your application to be using. So whatever you expect your application to be using is what you would want to reserve just for your application. And limits, so that can be considered somewhere around your minimum or average usage. Uh, and limits is the max that you would want your application to use. You don't want your application to use more than so and so amount of memory and CPU. So in this configuration, which is a very a sample deployment YAML configuration file that is in Kubernetes for a deployment, which has two different containers, one which is a Redis container and another a BusyBox container. So in this case, you could see that the requests, there's around 300 megabytes of memory requested for the Redis container, and there's around 100 megabytes of memory requested for your BusyBox container. Adding up, this is around 400 MIB of memory that your pod will basically need. Similarly, in terms of CPU, there's 500 M, which is milli-cores. Any vCPU can be considered as a single core, and that can be divided into 1,000 milli-cores. So these 1,000 milli-cores can be divided across your containers. So here we are requesting for around 500 milli-cores of CPU for the Redis container and 100 milli-cores for your BusyBox container, adding up to around 600 milli-cores. So this is a sample of how you can request your memory and your memory and CPU. And additionally, we have the concept of limits, which is the same way one CPU is requested here as the limit, which means that you won't be allowed to go over one CPU usage for this specific container. And similarly for memory as well, if it goes above 600 MIB of memory, it would restart the container. I can pause here for any questions. Just a quick pause. Or let me know if I'm going too fast. If you want more in depth or you want it at a higher level, just feel free to post that in the chat as well. Okay, so yeah, so basically this is a very basic sample deployment file, an example of how you can configure your requests of memory and CPU for your application in Kubernetes. Now, what essentially would happen to you if you like what essentially should your requests be at? What is the recommendation? What should the limits be at? Is what we can talk about. So the request itself. if so if imagine that this dark blue is actually what your application is using, you would want to keep your requests at a value which is a little higher than this, because you wouldn't want to opt for a lower amount of. Hi, Oliver. Yes, we can provide you a recording of the presentation and slides. Pushparaj, can you I mean, would we be sharing the slides as well?
Yeah, we can share that as well.
Okay, great. Yes, Oliver. So we will be sharing both of those. Thanks for joining. And yeah, so in terms of requests, you want to make sure that you give the request at a value which is a little higher than your actual usage. And yeah, we've all been there. Oliver. Yeah, thank you. So yeah, you make sure that your CPU requests are a bit higher than your actual usage, so that you have a fair margin to work with in case the traffic goes higher. But you also don't want it to be at the stage where it is a very large value. So imagine you have a very large value, and then it gets difficult to place that across any node. So suppose you actually need only two vCPUs, and you have eight CPU nodes, and you configure somewhere around six CPUs as your value for your CPU request. It is very unlikely that your node, which only has eight CPUs, is going to be only using two CPUs alternatively. So uh, the availability of having six CPUs within a node of eight CPUs is going to be very less. So in that way, one, it's going to make it hard for you to allocate your pod into any node. Second, in case even if you're able to allocate it, it's going to cause a lot of resource wastage because you actually only needed two CPUs in this example. So always make sure that you give a fair margin, but not too high a margin. Now, in terms of memory, the limits itself, yeah, the requests again can be a similar way where you give a little bit of a fair margin. But in terms of limits for memory and limits for CPU, they work in different ways. So a limit for a CPU will always cause CPU throttling, which means if you're making a request for one, I mean, if you're making a limit as one CPU, but your application actually needs two CPU, it will still run, but it will run slowly. It'll run in a not a very optimal performant way, which means it will use the one CPU. It will bottleneck your performance to the one CPU limit. Whereas if it is a case of memory, suppose you need actually 1.5 GB of memory for the application to run, but you're limiting it at 1 GB, it would actually restart the machine. So every time the memory reaches that limit, the pod gets restarted. So memory limits are something that you have to be a little more careful about, because this could lead to a crash loop back scenario where it keeps restarting. Because every time your application switches on, you're going to cross the memory limit, and the memory limit is going to cause your app to restart. And then again, this is going to be a loop scenario. So yeah, that's something that you might need to consider when you are thinking about memory and CPU limits. Now, in terms of CPU requests and limits, I just want to make an additional point. So this is something that a lot of people in the DevOps industry might contest. They might tell that this is not the optimal way, but this is what's been working for me, and I think it is most optimal in many cases. So it is about how do you want to configure your CPU requests and limits for CPU. Now, imagine a case that all pods have CPU limits and they have CPU requests. So, request is basically a guarantee that you are going to get that much amount of CPU for sure. Whereas limit is just you're definitely not going to get beyond that limit. Now, in case your pod has both CPU limits and requests, you are guaranteed that you will get a CPU between the request and limit. And that excess CPU, even if suppose you are limiting two CPUs and you're the only pod running in a 8 CPU node, that excess amount of CPU will not be allowed for you. You will be limited to the two CPU that you have requested. So even though you have a lot of extra CPU available there, you cannot use it. And imagine you have no CPU requests, but you have CPU limits. In this case, you are guaranteed the limit. So Kubernetes will basically automatically set the request as the limit value. So you don't get any excess CPU. The excess unavailable CPU is still not for you. But yeah, you will be guaranteed the limit amount. And imagine that you have no CPU requests and no CPU limits. It's like the Wild West, like it says, it's chaos here. You can get no one is guaranteed any CPU, no one is limited by any CPU. So any application can use whatever they want. So it will not be optimally placed. Now, in my professional opinion, in most cases, I am aware that in many cases this may not work out, but having no CPU limits but having CPU requests is what works, especially because one, you are guaranteed to have your requests value. Whatever you have requested, you will be getting. And along with that, suppose you are in a scenario where there is some additional in that node, there is some additional CPU available, you can use that. It's not wasted. And CPU will anyway be limited based on the node utilization. So uh, in most cases, it'll work when you have no CPU limits, which gives you that optimal use of CPU, but also the requested CPU values will make sure that you are placed according to approximately your CPU actual CPU usage. And CPU usage will vary based on traffic, but yeah, there's always scaling that comes in as well. Yeah, I can stop here. I think I spoke a lot on requests and limits in Kubernetes. Just quickly, if there's any questions required, please feel free to add that in chat. Feel free to put your questions in chat at any point during the webinar. But yeah, I hope it's clear on what requests and limits are in Kubernetes, how you can set your requests and limits, what could be your recommended values for limits and requests. Now, coming back to the problem that we faced with our client, what we realized is they've been running on Kubernetes for quite some time, but they hadn't optimally looked back at what they were doing across the years. They had a blanket deployment YAML file which had certain amount of requests and limits for all applications, and all of these applications were using the same value. So based on the actual utilization, they've never gone back and optimized their resource utilization. And that's exactly what we did. We went back to the drawing board. And this can be as simple as using a Google Sheet. But for getting the average and max values, we used Prometheus. We were running in that infra Prometheus and Grafana observability stack, monitoring stack. And using the Prometheus queries, we were able to get the average values of memory and CPU over a period of 7 days. And similarly, we also looked at the maximum value of CPU and memory over a period of 7 days. With this, one thing to know, I mean, there's two things to note. One, we need to negotiate the buffer. So different applications, depending on your microservice architecture, if you're running a Microsoft architecture and have different teams managing each service, you would want to negotiate the buffer. There would be some applications that are more critical and we need to ensure a higher buffer requirement. And also there's another thing to keep in mind that I will not talk about too much because again, that's going to take up quite some time is to make sure that you know the HPA target. So HPA is a horizontal pod autoscaler that is within the Kubernetes, which decides at what percentage of CPU utilization you would want CPU utilization or memory utilization you would want to scale to the next pod. You would want to increase a pod in your deployment. So if you, so one thing that happens is suppose you, and this is based on a percentage of your request value. So if you actually have an application that is usually running on a one CPU one CPU requirement, and you keep the one CPU itself as your uh, request CPU request value. We need to ensure that the HPA target is not going to be. I mean, if the HPA target is around 80%, so what happens is 80% of one CPU is going to be 800 millicores. Your pod is always going to be running more than 800 cores because it usually runs at one core. So what essentially will happen is your pod will if your max replicas the replica count which you can set, if the max replica is 5 or 10, it doesn't matter, it will always scale to the most number of nodes because you have told instructed Kubernetes that once my CPU utilization goes to 80% of one, which is 800 millicores, immediately scale the next pod. So that's where you need to keep that HPA target value in mind. You need to give a buffer in such a way that it is greater than that value. So if you actually run on one CPU by default, you would want your request to be maybe somewhere around 1.5 CPU, and your HPA target again, if it's at 80%, it's going to be more than that one mark, which means it will not simply keep scaling up. I know that may seem a little bit confusing, but it's actually fairly simple if when you like actually work around it. Yeah, so these were the thoughts that came across and what we worked across with. And we made sure that we got an average value, a max value. We got the application, we got more context on the applications to understand criticality, etc., with which we were able to identify what would be doing some basic math. We went for some requests which were recommended for memory, requests which were limits which are recommended for memory, and the CPU values as well. Now, like I said, CPU we didn't. We only went with requests, no limits, because that, in my opinion, that works better because we scale. We were scaling based on CPU as well. Okay. I'm assuming no questions. So this is well and good. This is a very manual approach, and the reason that it is a manual approach is because this is something that uh, went wrong over a period of time. So it's always nice to go deep into the numbers, into your applications, and identify and optimize as a one-time setup. And once you do this one-time setup, you want to make sure that you don't want to keep repeating this process. You don't want to have someone always check what the request values are, the limit values are they optimal? So that's where you would want to automate some of these things. And for the automation of resource usage and monitoring, there are monitoring tools, and so these are some of the tools that we used. But there are a lot more in the market. So Grafana and Prometheus, usually people use it bundled together, but Prometheus basically helps with your metrics collection, your data collection, this data which is then piped into Grafana for visualization, so that you can quickly see what is your requests percentage in terms of utilization based on percentage of utilization, what amount of node resources is being utilized, what amount of node resources is being requested and limited. All of these can be quickly seen based on dashboards that you create on Grafana, and that's something that we did for the client to ensure that they don't have to keep coming back to us whenever they come to this. They can just go through the dashboards and understand where they're going wrong. We also set some custom alerting rules to detect anomalies. So when there are points where there's uh, suddenly a very high increase in terms of maybe there was a deployment made, and because of that deployment, the memory usage of that application changed dramatically. I'm sorry, changed dramatically. In that case, you would get an alert. I mean, you can configure Prometheus alerts to ensure that you get an alert, and basically, based on what happened, dig in a little bit into what happened and see if there is a requirement to change your CPU values and your memory request and limit values. There are also some third-party tools. I've explored Cast AI, but I know KubeCost as well works. These are some third-party tools that on a generic cluster level can give you some details on terms of your requests, limits, what your Kubernetes optimization is like, and recommendations. But all of these would work best if you have actually gone deep into your infra, understood your application's context, made sure you've done one round of optimization before you start you start automating resource usage. Okay. Yeah, I see no further questions. So yeah, I'll just stop here in case you have any questions. If not, we have Q&A at the end. So yeah, what are our key takeaways? One, containers solve a lot of problems. Containers solve problems with running on my machine, but it's not running in your machine. They solve it better resource optimization and stuff like that. But containers don't solve all your problems. As you grow, as you scale, your containers are going to be a mess, even if you use something like Kubernetes, unless and until you have that set of resource optimization, monitoring the observability, and your fundamentals in terms of what the Kubernetes configuration is done right. So that is something that we need to keep in mind. And in terms of outcomes, so what basically this led to us is a 55% reduction, which is of a value that uh, a lot larger than we or our clients expected. But yeah, we were able to reduce reduce the EC2 costs by around 55%. Uh, the value that you see very high up in June and July is because they were June is where we started working on it, and they were on their reserved instances. So we needed to bring up new instances and stuff so that we can move across. And everything was stabilized and re-reserved in August, after which in September and October, we were able to see that dramatic reduction. And in terms of overall AWS spends, there was around a 37.5% reduction in overall AWS spends. This is not just because of EC2 instances, but this is also because of us digging deep into their network costs, migrating instances to, in some cases, to Graviton instances, which are cheaper, running on ARM, cheaper but very performant, making sure that their EVS volume costs don't add up. And even when you bring your node, the node count down, so the node count reduced to around 40% lesser than what it was. So bringing node count down also impacts reduction in EVS volume costs in terms of data transfer costs and all of these things. And we did some level of load balancing optimization as well, made sure that we use load balancers optimally. All of these, which can be different topics that we cover in different webinars. But yeah, these are some of the things that we have done, and with which we were able to approximately get around 37% of reduction in their overall AWS spends. Yeah, so that's what I had for you today. I hope that was helpful. I hope I wasn't going too fast, but I just wanted to make sure that I cover within the timeline that was allotted. But in case there are any questions or answers, please feel free to put it in the chat window, and then we can talk based on that.
Sure. I think that was good. Very insightful webinar, Rahul. Thanks a lot for that. I've got a couple of questions out here. One is, how does Quintype's approach to Kubernetes cost optimization differ from traditional methods? Can you share an example?
Uh, sure. So I wouldn't say Quintype's approach is a whole lot different from traditional methods, but what we have is we have experience running. So there are a lot of companies offering DevOps services out there. But what Quintype has is experience running their own infrastructure. All of our DevOps engineers work day in and day out on our own infrastructure as well. So there is some sort of expertise that we get, that we understand clients need to think about in the long term. So usually services companies, they work with a client for 6 months or maybe less than that, and they do a good job at that time, but then it again repeats. So we try to make sure that whenever we get involved, that it is a more sustainable long term change that we do in terms of cost optimization. We focus a lot on automating the cost optimization and as well, so that it can be a repeatable process. And yeah, those are some of the things that we do. And we start off with understanding what the application the customers are running, and digging deep into their costs.
Cool. There's another question, which is,
Yeah.
yeah, yeah, there's one
Yeah.
more question.
So yeah, I can see the question. So the question is managed Kubernetes or self-managed Kubernetes for beginners? What if cost is a concern? So if you are a small company starting off, a self-managed Kubernetes can work for you if you have the relevant expertise. If you're doing your own personal projects, definitely things like Minikube and self-managed Kubernetes will work. But in the long run, it is. I mean, depending on your technology expertise and the amount of engineers you have to spare, it might be better to go with a managed Kubernetes. That's where your cost of the cost associated with using a managed Kubernetes will be less compared to the cost that you have. You need to keep engineers involved, etc. I hope that answered your question, Shiva. Uh, okay, sure.
There's one
Uh,
question I have over here. What are the key metrics that organizations should monitor in real time to predict and control cloud cost effectively?
okay. Key metrics. So, I mean, key metrics that you would want to monitor is basically there's not one single metric, but it's mostly anomaly based. If there is a huge change in your cost in any of your services. So what we do at Quintype is we basically have uh, every month our invoices are automated into understanding what we divide it into services, and we make sure that each of these services are they using something compared to the are they costing a lot more this month as compared to the last 3 months. So this is something that we do to ensure that there is not any anomaly in cost. Other than that, in terms of metrics, I think something that really helps is making sure that your resources are tagged well. So a very good tagging structure. If you keep tags on all your resources, depending on which team is using what and how it was created by whom, you would be able to associate costs at a team level. And so what that does is that gives a division of responsibility. So if, for example, the platform team is using a lot more costs this month as compared to the other last 3 months, then this could be something that you reach out to them for and ask what happened. Uh, yeah, so those are some things that we keep in mind when we think about cloud cost.
Cool. Thank you. I think there's one last question I think we can take. How do automation and resource scaling contribute to sustainable DevOps practices, and what challenges should team be prepared to face?
Yeah, like I mentioned, automation is very important because you wouldn't want to keep managing your own infrastructure because you would want to keep innovating as a company. You would want to focus on things that bring you more business rather than focusing on keeping the lights running. So automation is very important in that way, and we need to ensure that people are not uh, going to be doing the same thing over and over again throughout the year. So once, like I said, sometimes it's good to have manual work wherein you dig in deep and understand the context. You know a lot. You know it a lot better than any machine or tool out there. But then once you have done that initial one-time setup and analysis, you would want to make this automated, and even in terms of scaling, etc., so that um, you can grow faster.
Awesome. Thanks, Rahul. I think we don't have any more questions. Thank you for this insightful webinar. I hope everyone learned about the request and limits and Kubernetes. We'll soon share the recording of this webinar along with the slides. And yeah, thank you for attending this webinar. See you soon. Bye-bye.